Now we're going to be getting into chapter 5, which is the analytic piece of the trig functions. So that word analytic means we are going to be using them to kind of rewrite them using different definitions or to solve or verify. So we're going to be doing a couple different things, kind of extending them from their regular use on the unit circle. So I already had you copy these down in your notes, but they're here for you as well. When we are using the identities to evaluate a function, there are some rules that we want to be made aware of. So this little box here just kind of talks about the positive and negative rules, which are important. So when will tangent be positive? Well, that means that sine and cosine have to have the same sign. So they're either both positive or both negative. When tangent is negative, that's if sine and cosine have opposite signs. So if one is positive and one is negative. So that is going to help us when we're evaluating, is tangent positive or is it negative here? And then sine and cosecant always have the same sign, whether it's positive or negative. They always match, and cosine and secant always match. And I should have put there too, tangent and cotangent always match as well. All right, so moving on to this example. So it says, use the value cosecant of x equals 2 and tangent of x equals square root of 3 over 3 to find the values of the 6 trig functions. So we already have 2 of those functions, but they want us to find all 6. So we need to use these properties. Now, when we set this up, I always like to start by writing out sine, cosine, tangent, cosecant, secant, cotangent. So let's do that first. All right, so there they are. So we already know 2 of these. We know that cosecant is 2, so we're going to fill that one in. And then we know that tangent is the square root of 3 over 3. So we are going to fill that one in. All right, so now we need to figure out the other 4. So going off of our identities, we can use the reciprocal identities to find sine and to find cotangent. And we already know that. We don't necessarily have to look at these. We know that sine is the flip of cosecant and cotangent is the flip of tangent. But still, keep in mind you are using these reciprocal identities. So for instance, cosecant equals 2, and cosecant is 1 over sine. So if we wanted to find sine, what does sine equal? It equals 1 over cosecant, so 1 over 2. So that is what we get for the value of sine. So we're going to fill that one in. So we get 1/2, and then the same thing down here. Cotangent is the flip of tangent, so we're going to flip this fraction over. All right, so cotangent, we found that because cotangent is 1 over tangent. So 1 over this becomes 3 over the square root of 3. So now we do have to rationalize the denominator, so that's where we get that square root out of the denominator. A little bit bigger. So we want to multiply by root 3 over root 3. All right, so when I do that, multiply by root 3 over 3, I end up getting 3 times root 3 on top, and then the square root of 3 times the square root of 3 is the square root of 9, which is just 3. And then I can cancel out these 3's to get a final answer of just the square root of 3. So that would be cotangent. So now how do we find cosine and secant? So now we have to use one of these other definitions. The good one to always go to that pretty much works whenever you have either a sine or cosine value is this Pythagorean identity, sine squared u plus cosine squared u minus 1. So keep in mind u is the same thing as x. It's just a different variable letter. So because we have sine and we want to find cosine, we can use this identity. Another one we could use would be this identity here. So we have tangent and we have sine and we're looking for cosine. So we could use that one, but let's not get fractions involved here. So let's use the Pythagorean identity one, and that's going to help us to find cosine. So we are going to do sine squared u plus cosine squared u minus 1. So I'm going to write that out. So here when I wrote that out, instead of putting a u, I put an x because our variable is x, not u, but it's interchangeable. So now we want to fill in what we have. We have sine. So we have sine is 1/2, but here it asks for sine squared. So we need to square 1/2. So instead of just having 1/2, we square 1/2. And we don't know cosine, so we just leave that all the same. So 1/2 squared is 1/4. So we have 1/4 plus cosine squared x equals 1. So we want to subtract over the 1/4 onto the other side. And that means that we need a common denominator for 1 here. So we are going to write 1 as 4/4 because that is the same thing as 1, and it gives us a common denominator. So now when we subtract 1/4 from both sides, we end up getting cosine squared x equals 3/4. Now the last thing we need to do is get rid of this square. So to get rid of a square, we need to square root. We're going to square root both sides. So what we end up getting here is cosine of x equals the square root of 3 over the square root of 4, which the square root of 4 is 2. So we can write this as equals the square root of 3 over 2. So we get the square root of 3 over 2, so we can plug that in for cosine. And if cosine is the square root of 3 over 2, secant is the reciprocal, so it's going to be 2 over the square root of 3. Once again, we have to multiply the top and bottom by root 3, just like we did for cotangent to get that radical out of the denominator. This time when we do that, we get 2 square root 3 over 3, and we can just leave it as is because nothing cancels out.